welcome to the notes on multiplying polynomials. Okay, so we've looked at polynomials times monomials. Now we're going to actually look at binomials times each other using a method called FOIL, and we're also going to look at how to use it, how to do it using the distributive property. And I'm actually going to show you a couple other ways also. So multiplying binomials. To multiply two binomials, such as these ones right here, right there. We can use the distributive property. Okay, we can use the distributive property and we can multiply them horizontally or vertically. Okay, and here's what that looks like. The distributive property is basically we're going to take the whole thing and multiply it by each part. Okay, to do that vertically, we set it up like this, just the same way you set up problems when you were, if you're multiplying 43 times 27, and you multiply the 7 times the 3, and you get 21, and then that 7 times 4 is 28, plus 2 is 30, and you would do that first line, and then you move over one spot. 2 times 3 is 6, and 2 times 4 is 8, and then we add everything up, and we get 1161. Well, this is the same exact idea. We're going to multiply by everything right here by 5, and then we're going to multiply everything right here by the x, and then we're going to add those to get the sum total. Okay. We can also do it horizontally. I would not suggest that. But if you want to, it's not bad to understand it. Basically what happens is we take 2x and we multiply that by both terms, and then we also take the 3 and we multiply that by both terms, which is what happened here. And then we have, right here in the middle, we have our like terms, and then we add everything up. Now, that horizontal method we're going to come back to in a little because it looks a lot like what FOIL really is. I want to show you I want to show you something else. So let's take a look. Let's grab this. And I'm going to show you a couple other things because some of you guys are in classes right now that actually might help us with this. So let's go here. Okay. So we have this. Yikes. We have these same two. Okay. First, let me show you. We worked with those algebra tiles. Okay, that day that we took algebra tiles out and we've worked with these. So what if I modeled this in algebra tiles? Okay, and I had my green one right here, and then another one for this is 2x plus 3, and then my yellow ones for 3, and then I have x plus 5. So I have x and then plus 5, 2, 3, 4, 5. The neat thing here is that all I have to do is take each intersection of the tiles, and I'm literally going to create a bunch of squares, okay, and a bunch of rectangles, and then maybe a couple large squares. And all I have to do now is count. Okay, I have 2x squared. Let's get rid of this stuff here at the bottom. I have 2x squared because this is an x squared and this is an x squared. So I have 2x squared. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13x. And then I have 3 times 5. So this is 15 right here of just the constants. So I could draw algebra tiles and do it just like that. Some of you guys are in biology. Raise your hand if you're in biology. If you just raised your hand, that's funny. Okay. And you guys are familiar with this idea of Punnett squares. Okay? So, if you're in biology and you're doing, I have dominant, I have brown eyes, but I have a heterogeneous mix. And my wife has blue eyes. And we want to see what will our kids have. So we do this for eye color. And we see that our kids have a 50-50 shot of having blue eyes or brown eyes for eye color. So Punnett squares. If you've never seen that, you're welcome, but odds are most of you have seen that. So we can use Punnett squares to multiply two binomials. Okay, same idea. I just set up 2x and 3 and x, and I can put the plus if I want, plus 5. And then I multiply 2x squared. I multiply here and get 10x. I multiply 3 times x and get 3x, and then 3 times 5 and get 15. The only thing I have to remember here is that my like terms, they end up being diagonal from each other, so I have 2x squared plus 13x plus 15. Same thing I got right here, just another way to do it. So you can choose either one of those also. I thoroughly don't care which way you do it, just as long as you have a way. Okay, let's go back and look. So, all the example B is stressing is sign. Lots of sign error mistakes are made here, so please be careful. Negative times a positive is a negative. Negative times a negative is a positive. And of course, positive times positive is positive. But that's just stressing sign error. There's that again. Thank you for that. So 1A, 1B, pick the method of your choosing, or maybe try to do a different method each time. But try those two. Pause the video here. Try those and get some answers. Ready? Go ahead and pause the video now. Get some answers to 1A and 1B. All right, you are back from pausing. Hopefully for 1A, you got 3m squared plus 19m plus 20. Hopefully for 1B, you got 5y squared plus 38y minus 16. If you didn't, pause the video here, go back, erase your work, try again, see if you can find your mistake. Try a different method. If you did, good job, on we go. Let's talk about FOIL, okay? FOIL it's a shortcut version of the distributive property. It's just a way of remembering it. FOIL is a mnemonic device, okay? Each letter stands for something. First, outer, inner, last. First, outer, inner, and last. So that's what we do. When given this setup right here, we're going to go first terms times first terms. Then we're going to go, let's see if I can stay with their colors. Then we're going to go outer term times outer term, and actually circle the sign there because that matters. Then we're going to go inner times inner, and then we're going to go last times last. Okay? I do all that. My like terms end up being right here in the middle. I combine those, and I'm all set. Okay? Only difference here now is so the examples, there's some leading coefficients or the signs. Again, sign error is the big area of mistakes here. We got to be really careful not to make sign error. Go ahead and pause the video right here. Try, this time don't do any method other than FOIL. Try just the FOIL method and see what you get. Go ahead and pause the video now and do that. All right, you're back from pausing. Let's go ahead and check these. Hopefully for 2A, you got 2x squared minus x minus 12. For 2B, you got 12b squared minus 7b minus 10. For 2C, we have 2y squared minus 17y plus 30. And for 2D, we got 15a squared minus 14a plus 6a. Okay, oops, sorry. Hold on now. Minus 14a, sorry, minus 8. Whoa. Minus 8, okay. If you didn't, go back, try those with one of the methods that maybe you were better at before and see if you can find your mistake. A couple things to notice: when we multiply two linear expressions, we get a quadratic. So what we're saying there is that right here, this is a linear expression, and this is a linear expression. Linear times linear gives us a quadratic, because now we have 2 as an exponent. If 3 linear expressions were multiplied, we'd have a degree of 3, so we'd have a cubic expression. Okay? Let's take a look. So this is a really good problem, very common testing problem. We have a swimming pool and we have a deck around it, and we want to know an expression for the total area of the pool and the deck. So we know the pool is 20, and then this is x, and this is x. The width, the length is 15, and then this is x, and then this is x. So what we have is for the total width, we have 20 plus 2x, okay? And for the total length, we have 15 plus 2x. So there they are. We multiply them out, and we get a quadratic expression for the pool. Suppose the same pool is 25 feet long and 20 feet wide. Find the area of the pool for that one. So go ahead and pause the video right now. Really, guys, this shouldn't be that hard. We're taking 20 and 15 out, putting 25 and 20 in. Pause the video right now. Try and get the answer to that. Go ahead and pause. All right, you're back from pausing. Hopefully you got 2x for the problem. You got 2x plus 25 times 2x plus 20. All right. For your answer, you got 4x squared plus 95x sorry, not 95. Yikes. 2 times 25 is 50. 2 times 20 is 40. That's 90x plus, and then 20 times 25 is 500. Okay. We can use the distributive property to multiply any two polynomials. So now we have a binomial and we have a quadratic trinomial. And so all we do is, we can't really use FOIL because these aren't both binomials, but what we can do is we can say, all right, we're going to take 6x times each one of these, and then we're going to take 5 times each one of these, and then we're going to find all the like terms and add them up. I think that if you like the Punnett square method, that works here also, because I could just do 6x and 5. I'm just going to make a different size Punnett square. And then up here I'd have 2x squared minus 3x minus 5. And then I do the same thing. I use my 2x and 6x to get 12x cubed. And then I do all the same things in here, negative 18x minus 30x and so on, and then combine the like terms, okay? So very same concept, just a little bit more work intensive. Go ahead and pause the video here, and I'll walk you through actually let's do this. I'll walk you through 4a, and then you can do 4b on your own. Okay, I'll walk you through, hold on, sorry about that. Let's get this stuff out of our way. I'll walk you through 4a, and then you do 4b on your own. So let's take a look at 4a. If we just distribute, I'm going to take 3x times each one of these. So I have 6x cubed plus 21x minus 21x squared. Then I'm going to take the negative 5 times each. Okay, and actually we'll do a different color here so we can really see what we're doing. So negative 5 times each one of these. So this is minus 10x squared minus 35x plus 40. Okay, so now I have all that. Let's move you over here. And then all I have to do from here is just find the like terms. Okay, so from here, pretty much 6x cubed is the only cubed term. 21x squared and negative 10x squared gives me 11x squared. Negative 24x and negative 35x is negative 59x, and then all that we're left with is plus 40. Okay, go ahead and pause the video right here. See if you can get an answer for 4b. Go ahead and pause the video now. All right, you're back. Hopefully for the answer for 4b, you got 4m to the 4th plus m cubed minus 21m squared plus 31m minus 15. If you didn't, I would say try that one again. There's a lot of things going on, a lot of work to do in that problem. So try that again, see if you can come up with the answer. If you're still stuck, make sure you make note of it so in class we can go over that one, make sure that everybody's on the same page. Okay? After that, what I would like for you to do is try some of these. Okay? Try these 1 through 11. Pick some different methods. Go about it a different way. See if you can come up with, which way you're best at. Find those, and we will check them next time. I will see you guys later. And make sure, please, share the video or like the video or tweet the video or something so that everybody's seeing this. This is not easy stuff to do, especially if we haven't watched the video. All right, see you guys next time. Bye.